Hello YouTube fam, welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we will discuss about fine-tuning a llama2 model. Fine-tuning text generation models can enhance their performance for particular use cases. For example, we can use fine-tuning if we want to modify the tone and format of the output. This work incorporates insights and code snippets courtesy of HuggingFace, published on HuggingFace's blog. We extend our gratitude to the original authors and HuggingFace for sharing their valuable resources with the community. We will run this code on Google Colab with T4 GPU. We will install the following libraries like TRL, which stands for Transformer Reinforcement Learning, Transformers, which provides APIs and tools to easily download and train state-of-the-art pre-trained models. Before we implement the fine-tuning, let us start with understanding of basic concepts. The first concept is PEFT, which stands for Parameter Efficient Fine-Tuning. Parameter Efficient Fine-Tuning, PEFT, refers to a set of techniques in machine learning aimed at updating large pre-trained models in a way that requires altering only a small fraction of the model's parameters. This approach is particularly useful when working with very large models, such as those used in natural language processing and computer vision, where full model retraining can be prohibitively expensive in terms of computational resources and time. Next concept is LORA. In the context of parameter-efficient fine-tuning for machine learning models, LORA and QLORA refer to specific techniques designed to update large pre-trained models more efficiently. Let us look at LORA, which stands for Low-Rank Adaptation. Low-rank adaptation is a technique used to fine-tune large pre-trained models in a parameter-efficient manner. Instead of updating all the parameters of a model, LORA focuses on adapting only a small set of parameters, typically by introducing and training low-rank matrices that modify the weights of specific layers, like the attention or feed-forward layers in a transformer model. This approach allows for significant customization of the model to new tasks with minimal changes to the overall parameter set, preserving the original strengths of the pre-trained model while adapting it to specific needs. Imagine you have a huge, complex book representing a large pre-trained model that you want to customize slightly without rewriting the whole thing. LORA allows you to do just that by adding a few notes or annotations, small changes, to some pages, making the book more relevant to your specific needs without altering its original content significantly. Next up, we will look at QLORA, Quantized LORA Adaptation. Quantization, in the context of machine learning, involves reducing the precision of the numerical representations used in a model. For example, reducing floating point numbers from 32-bit to 8-bit integers. This process helps decrease the model's memory footprint and can speed up inference, making the model more efficient, especially on hardware with limited computational resources or specific accelerators designed to work with lower precision arithmetic. Building on the previous analogy, if LORA is like adding handwritten notes to the book, QLORA is akin to using a shorthand or a more condensed notation for those notes. QLORA further compresses the changes you make by quantizing them, which means representing these adjustments with fewer bits. We will use TRL and HuggingFace SFT. Transformer Reinforcement Learning is a library to train transformer language models with reinforcement learning using different steps. HuggingFace SFT refers to the traditional approach of fine-tuning a pre-trained language model on a labeled dataset specific to a target task. This process involves continuing the training of the entire model on a smaller task-specific dataset, allowing the model to adjust its weights to perform well on this new task. Let us start with code implementation for fine-tuning the llama2 model. We will fine-tune it to behave like a conversational chatbot. Let us begin with step 1, load dataset. We're going to play around with this cool thing called the Guanaco dataset. It's basically a neat tidy little piece of the bigger Open Assistant dataset, and it's tweaked just right for training chatbots that can do a bit of everything. It consists of human and assistant messages in conversational format. The sample format is human, can you explain ABC, for which the assistant replies, assistant, ABC is this, and that, and so on. In step 2, we will load the base model. We will use the TinyPixel llama2 7B F6 sharded model. We will quantize in 4-bit. First import AutoModel for causal LM, AutoTokenizer, bits and bytes config, AutoTokenizer. Then, load the base model using AutoModel for causal LM dot from pre-trained function. In step 3, we will load tokenizer. We will use load tokener using AutoTokenizer dot from pre-trained. Before we fine-tune the model, let us run inference on the base model. Once we run inference on the base untuned model, we can see that it is just predicting the next words or sentences. Once we input our prompts, it just gives similar words or sentences and what could be the next sentence. These just look like simple sentence completions. For example, for the prompt, how to make an iPhone, it comes back with responses like iPhone 3GS wallpapers, iPhone 6S Plus, iPhone 7, 48 iPhone 6 Plus wallpaper, 1600 iPhone 6 Plus wallpaper, and so on. Another example for the prompt, give a intro about economy, it comes back with responses like give a intro about the economy of the United States, give a intro about the economy of Japan, give a intro about the economy of China, give a intro about the economy of India, and so on. It's not doing any response in the conversational assistant format, which is what we need it to do. This is the reason we will fine-tune the base model based on conversational dataset. Once we fine-tune, we will use the same prompts and see how the model produces responses in conversational assistant format. In step 4, we set up LORA config and PEFT config. We will load the configuration file in order to create the LORA model. It is important to consider all linear layers in the transformer block for maximum performance. We will set target modules QProj, VProj, KProj. In step 5, we will be loading the trainer. Here we will use the SFT Trainer from TRL library that gives a wrapper around Transformers Trainer to easily fine-tune models on instruction-based datasets using PEFT adapters. In step 6, we will train the model by calling trainer.train. Note, when prompted for weights and balances API key, enter it. We can sign up for 1B using Google account for free. During training, the model should converge. Finally, we will save the model. The SFT Trainer also takes care of properly saving only the adapters during training instead of saving the entire model. We can also publish the model to HF Hub. The model is saved in the cache memory by default. We can load it from output directory and create new tokenizer and run generate on the model. For our example, we will use the pipeline and model from cache. Finally, in step 7, we will run inference on the fine-tuned model. Once we run inference on the fine-tuned model, we can see that it gives responses in the conversational assistant format, which is what we need it to do. For example, for the prompt how to make an iPhone, it comes back with responses like answer. If you are using Xcode 4.5, then use the simulators provided by the simulator itself. It is much faster than the simulators provided by Xcode. Another answer, you can use the simulator in Xcode to run your app on an iPhone or iPad. If you have an iPhone, you can also download the iOS SDK and install the device simulator to run your application on that. For the second example, for the prompt, give a intro about economy, it comes back with responses like, economy is the way we use the resources we have available, such as money, land, and labor, to produce things that we need and want for our society. It is a system of trade and exchange where people and businesses buy and sell goods and services in order to meet their needs and desires. Economic systems are different from place to place and from time to time, but the goal is always to maximize our resources and use them in the most efficient way possible. From the above examples, we can clearly see that fine-tuned model has understanding of the conversational pattern we wanted it to learn. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning. If you found this video helpful, don't forget to hit that like button, Subscribe for more tech talks and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.